Today's topic I have found to be a little bit confusing for some kids, and I also feel like this is one of the things that the textbook really doesn't do a great job of explaining. So I'm going to build it from the basics, starting with stuff that you know, and hopefully lay a foundation for you to be able to do this. Honestly, in the end, the math is really easy. It's the understanding why that can be a little elusive. But let's begin with something that you've already seen. Well, actually, let's go back even further. If I say the absolute value of -5, we know that that is 5. I also know that the absolute value of +5 is 5 because going way back, absolute value can be thought of as the distance from 0. It's always positive. You can't really have a negative distance. So let's say that I say the absolute value of some number, x, is 5. We learned earlier in the year that based on the idea that a solution is anything that makes an equation true when you plug it in, this can have two solutions. It can be either -4, 5, or +5, because we've seen here and here that if I plug that in, for x, it is true. Each one of these is true. The absolute value of -5 is 5, and the absolute value of +5 is 5. So, let's say that the absolute value of a number is greater than or equal to 5. If I look at this, I can think of a number line, and I can say clearly the absolute value of x is greater than or equal to 5. Well, I've got a closed dot. It could be 5. It could be anything greater than 5. Let's think about the negative numbers, though, that have an absolute value that's greater than 5 or equal to. So I can say, well, clearly -5 has an absolute value that's greater than or equal to 5 because its absolute value is 5. What about -7? What's the absolute value of -7? Oh, it's +7. And since 7 is greater than equal to 5, if I say the absolute value of -7, is that true? Yes, because the absolute value of 7 is -7 is 7, and 7 is greater than or equal to 5. And you can see as I go to the left on my number line, the absolute value increases. The absolute value of -6 is +6, and 6 is greater than 5. And the further away I get, the greater the absolute value. So it's important. This is really the jumping off point that matters. It is really important for you to understand that if I say the absolute value of a number is greater than or equal to 5, it could be either greater than or equal to +5 or less than or equal to -5. If this is a problem for you, I want you to pause the video and just play with that idea a bit. That stands to reason then, if the absolute value of x is, I don't know, let's say less than or equal to 3. Now we're doing less than. Okay, so let's think of the numbers that work. The numbers that work are clearly, if I start with my closed dot at 3, then 2, 1, 0, all of these numbers work because they're less than or equal to 3. And then I could go -3 has an absolute value that's less than or equal to 3. And just like in the other one, now it's all the numbers that are greater than or equal to -3. So if my absolute value is less than or equal to 3, it could be any of these numbers in here. It could be 2, it could be 1, it could be 0, it could be -1, -2, or -3. So in the end, x is less than or equal to 3, and x is greater than or equal to negative 3. If I go back to the way we were doing things yesterday, I would start from the smallest. I would say negative 3 is less than or equal to x, which is less than or equal to 3. Going back to my one with the absolute value of x being greater than or equal to 5 from the previous slide, what we saw on that one was that to have an absolute value greater than or equal to 5, you're either greater than or equal to 5 or less than or equal to negative 5. Because on the negative side of things, absolute value increases as the numbers get smaller and increases as the numbers get large, or decrease as the numbers get larger. So, I'm not sure if I said that right, because I was thinking about something else. So x, in this one, x is greater than or equal to 5, or x is less than or equal to negative 5. In this one, x is between. Notice that this is like a conjunction, and it goes with less than or equal to. And this is like a disjunction. It goes with greater than or equal to. So based on that are a little bit more elusive. Well, let's start with the idea that the absolute value of y minus 2 is equal to 4. What I know then is, let's just call this whole thing. I know that something in here has an absolute value that's equal to 4. And we know if something has an absolute value equal to 4, then it either equals 4 or it equals negative 4. Okay? So if that something is y minus 2, then either y minus 2 equals 4 or y minus 2 equals negative 4. If I solve these, I find out that y could either be 6 or y could be negative 2. And the reason is, if I plug those in, it will make it true. 6 minus 2 has an absolute value of 4, and negative 2 minus 2 also has an absolute value of 4, because this one is the absolute value of 4 is 4, and this one is the absolute value of negative 4 is 4. In other words, if what's inside of here has an absolute value of 4, then what's inside of here either equals 4 or it equals negative 4. And the way I'd graph that is I'd just go and I could say that my two solutions are 6 and negative 2. So I'd put one of them here, negative 2, and one of them here, 6. They're equal to, so they're dots right on here. Concept to the idea that the absolute value of x plus 1 is less than or equal to 3. Again, I know that whatever's inside of there has an absolute value that's less than or equal to 3. And I know from previous experience that means that that number is either less than or equal to 3 or greater than or equal to negative 3. Think of those slides before. But instead of just one number now, this is an x plus 1. So if x plus 1 is, the absolute value of x plus 1 is less than or equal to 3, then x plus 1, that number, has to either be less than or equal to 3, or it has to be greater than or equal to negative 3. X is less than or equal to 2, or x is greater than or equal to negative 4. When I go to graph these, first of all, the best thing to do, since these go negative 4 is less than or equal to x, which is less than or equal to 2, it's best to state it like that. We've got negative 4, we've got 2, Let's put it in here. All right, let's check a few of these. Let's plug in -3. Does -3 work for this? Is -3 the absolute value of -3 plus 1 less than or equal to 3? Well, that's -2. And 2 is, the absolute value of -2 is 2. That is less than or equal to 3. Let's try one on the positive side. Let's put in 1. Is the absolute value of 1 plus 1 less than or equal to 3? The absolute value of 2 is less than or equal to, yes. 2 is less than or equal to 3. So those are the checks. This is what it looks like. But the key is to divide it into the two things that must be true. If I say, going back to the beginning, if I know that the absolute value of some quantity, the quantity x plus 1, is less than or equal to 3, then the way I want to begin is by saying that means that x plus 1 is less than or equal to 3, and x plus 1 is greater than or equal to -3. And from there, you solve. The absolute value of x minus 3 is greater than 2. Okay? If I know that the absolute value of some number is greater than 2 or equal to 2, then I know that that number, and this is x minus 3, that number has to either be greater than or equal to 2 or less than or equal to -2. X minus 3 is the quantity. I solve it. So I find out that x is greater than or equal to 5, or x is less than or equal to 1. I then graph that. It's a disjunction. We've got 5 going this way and 1 going this way. I know that it can take a while to wrap your brain around this, and hopefully you got the idea in class. Basic steps. If you have an inequality that starts out inside of absolute value, if I say that, for example, the absolute value of x plus 5 is greater than 2. So you start here. The first thing you want to do is separate into two inequalities. The first one is just what you would get if you take it out of the absolute value. So x plus 5 is greater than 2. The second one is the same thing, x plus 5, but now you switch the sign and make it the opposite. Switch sign, make opposite. When you solve these two things, you will find that x is greater than -3, or x is less than -7. And when you go and you plug those back in, you will find out that it's true. All of those numbers will work. After that, you just make sure that you solve and you graph. Don't be worried if this is a little bit hard for you to understand. At least be able to do the math and keep going back over it and thinking about what it is that you're doing, and how absolute value works, especially on the negative side of things.